All right, so previously I went over selecting a scope and a rifle setup for long-range shooting and how to set up, and install a scope on the rifle. Talked a little bit about fundamentals of marksmanship for rifle shooting at long range. And now I want to go over just a little bit about zeroing the gun and collecting your data at the range so that you can get your drop information for your gun and cartridge that you're shooting. And that's going to give you the data you need to set up a ballistic calculator and generate some dope cards that you can use when you're shooting long range. So the first thing I should go over real quick is just getting a bore sight on your gun to get an initial setting on your scope that'll get you on paper at 100 yards. And to do that, I think the easiest thing to do, rather than spend some money on lasers and things like that, is to just pull the bolt out of your gun. If you're using bolt action, it's pretty simple. Just drop the bolt, set the gun up on the bipod and a sandbag or a couple of sandbags, whatever you've got. Make sure that you can get the gun really stable and not disturb it. And then set up a target at, say, 25, 30 yards. And eyeball through the bore from the back of the gun. And make whatever adjustments you need to do so that the gun's settled in on the bag and the target is centered up in the bore. If you're using an AR type of platform, pretty easy. Take the upper off if you have to. Pull the bolt carrier out. Same thing. Rest it on sandbags. Just get the target centered up in the middle of the bore, and then raise up your eye a little bit. Look through the scope. Try to get your windage dialed in as good as you can to the center of the target while it's centered in the bore, and then I like to leave the crosshair, inch and a half, 2 inches high, whatever, just kind of estimate it. Leave it a little high, the center of the target on the paper. If you center it up at that distance, you're probably going to be shooting over the paper at 100 yards or, depending on the size of your target that you use, but you're going to be off probably pretty high at that point. So leave the reticle a little bit above the target at that distance, and then once you've got that settled in and you're happy with it, you're ready to move on out to 100 yards and fire some shots to make your initial adjustments on your scope. And the first thing I would do is just do some dry fire practice, set up a really good solid shooting position. Make sure that you are ready to fire a well-aimed shot and take one shot. Look at the offset of wherever your point of impact was versus your point of aim. Hopefully you have a scope that's got a reticle that's graduated, that matches your turrets so that you can get a measurement using your reticle. And you just, I usually will just move across the target, so that like in windage, I'll move over across the target until my vertical crosshair is lined up with the bullet impact. And then I just measure how far down it is on the vertical reticle and how far to either side it is on the horizontal part of the reticle, and then just translate that into adjustments on the turrets. So make that initial adjustment, and then fire a few shots at the target to get kind of the startings of a group established. See if you need to make any more adjustments, and then make another adjustment if you have to. If you're still off a little bit, come up a couple clicks, whatever you got to do. With something like a mil scope, you have usually 0.1 mil increments, in your clicks, and that's going to be like 0.36 inches at 100 yards. So you may not necessarily be able to get a perfectly centered zero. That's not a huge deal. If you have to err to either side of your aiming point, the bullseye or whatever, I like to err, towards the high side and towards the left. There's a little bit of spin drift at long range. So the bullet's going to track a little bit to the right. It's not much, a few inches, maybe over 1,000 yards. So if you err, if you're like in between clicks, if you err to the left side of the bullseye, then that's just going to, help to cancel out a little bit of that spin drift at long range anyway. So I err towards the high side, towards the left, and then, make sure I've got one good group that I can take the average of the center of that group, and as long as that is within one click of center on the target, I call it good and move on. So at that point, if you're comfortable with your 0, we'll move on out to whatever you've got, to where you can shoot long range, and you're going to want to gather some data on the gun. So I'm going to show a video of how I do that. You can get a lot done if you can just shoot at 600 and 900 yards, which is what I've been doing for a while as far as just getting some initial data for the gun. It's best if you have the opportunity to shoot in 100-yard increments and gather data at every 100-yard line. That's just going to give you more information to go off of. But you can get really close with most ballistic calculators with your drop at 600 and 900 yards and record your environmental conditions, get as accurate of environmental data for the time you're shooting as you can, record that in a notebook, record your drops, and then we'll come back and talk about truing up a ballistic calculator a little bit. So I'm going to cut over to the video at the range and then come back after that and talk a little bit about the ballistic apps. All right, I'm out at the range. I've got a little bit of time here. I'm going to try to do a quick data collection video and just show you how I would get my initial data to true up a ballistic calculator. And this range has berms every 100 yards with different size targets. So I can get down to smaller targets and get a pretty good idea of exactly where my impact is going to be. To true up a ballistic calculator, you want to at least have your 600 drop and your 900 drop on something like a 308 so that you can true up your muzzle velocity in the app or the Kestrel at the 600 yard mark, and then true up your BC at like 900 yards, something like that. Those 2 points will get you enough data to get pretty accurate results from a ballistic calculator. If you can, and you have the opportunity to shoot in 100-yard increments, then it's a good idea to just go ahead and get your dope. But rather than just rely on a ballistic calculator and the info that's on the ammo box, it's always better to come out and verify your drops in real life. Write that information down. You want to record as accurate of atmospheric data as you can get. So if you don't have a Kestrel, try to get the best local reports, like off a nearby airport or something like that, off your phone if you can find an app that'll give you that information. So you're going to want to have your temperature, your station pressure, so like an uncorrected barometric pressure, the actual air pressure at your location if you can get it, humidity doesn't really, you can put 50% humidity most of the time in an app and just go with that. Humidity doesn't make a huge difference until you're talking about maybe like really big swings in humidity at really, really long ranges. But, for 1,000-yard stuff, just set it at 50% is what I normally do. So anyway, we're going to go ahead and we get some through the scope video and try to just show you that, you can pretty quickly gather some information with your gun. And if you're using a good ballistic app and you have good data in it, then it's going to give you some pretty accurate information. So I'll record some drop information, just write it in my notebook, and then when I'm done shooting or later on or whatever, I'll mess with my Kestrel or my app and make the adjustments in there to make everything match what I'm seeing on the paper that I recorded in the field. So let's go ahead out to 600 yards. Where am I? That's 3. I think I need about 5 mils for 600 yards. That should be that. And we're going to check our level, preload the bipod a little bit. It's like a 7:30, 8 o'clock wind, 2 to 4 miles an hour. I want to make sure the gun's level. I want to try about a bracket this target, basically shoot left edge. A little off the right. All right. Good, about 1/2 mil. Oh, yeah, this wind's kind of hard to judge the way it's coming up behind me and switching back and forth. Looks like my elevation's about right here. There we go. All right. So, 5 mils is good for 600. So I can write that down. Now, run out to 900, and that should be about 10 mils on this gun. Now, let's look for that 900-yard target. All right, so check my level. I'm going to hold about a 1/2 mil on this one. Yeah, maybe 3/4. And just off the left edge, it looks like my elevation is about right for that. There we go. All right, an impact on that. Looks like my data's good at 10 mils for 900 yards. And I can work back a little bit. 800 should be 8.1. All right. All right, here. Aim for the small target here, just off the left edge. All right, impact. So 8.1 looks good for 800. Bump my legs up a little bit for this one. 900, there's 1,000. This should put me, let's see what I'm at, 12.3. Yeah, let's see if that's right. There we go, impact. So 12.3 for 1,000. All right, I went to the range with this gun and I shot it at 600, 800, 900, and 1,000 yards. I used smaller targets that I had available so that I could make sure that my adjustments for elevation were as precise as possible. I didn't really have any clean targets with fresh paint on them, so I opted to use the smallest targets available. If you have clean targets, if you have steel especially, and you can paint it fresh and put a watermark or a horizontal line painted across the target that you can use as a reference point so that you're always aiming for the same point on the target, and then you can see if your impacts are high or low. That's a good thing to do. If you don't have any steel available, but you have target stands, and you can use white paper and just draw a horizontal line on the paper, with a Sharpie or something like that. It's nice if you have a clean piece of steel, with fresh paint and a water line on it. That's probably the best thing you can use. But there are other things. If you don't mind going out and checking paper at that distance, you can do that. But anyway, you want to get your elevation adjustments as precise as you can get it at those ranges, so that when you transfer this information into your ballistic calculator, you have accurate real-world information to true up your ballistic calculator to compare the results that the app or whatever is giving you to what you got, and try to make them align. So I did a post a while back about how to set up a Kestrel, and I think I had some information there about just setting up ballistic apps in general. So I'm going to share that post again so that you have something to look at as far as setting up ballistic calculators. The main thing you want to do is make sure that your information, your inputs into the ballistic calculator are as accurate as possible. And one of the big ones is getting the center line of your scope to the center line of your barrel. Get that measurement as accurate as you can where the turrets are. Right? So you want to know, like say right in front of the turret housing, what's the distance? I think it's 1.93 inches on this gun. It's 2.75 inches on my other gun. So get that measurement, put that in the ballistic calculator, and also get your zero range as close to 100 yards as you can get it. And it should be 100 yards from your turrets to the target. So use a measuring tape if you have that available, or a rangefinder that's accurate, to a tenth of a yard or something like that. And, take a little time, set up your gun, make sure it's as close to 100 yards from the target to the turrets as you can get it. You don't want to be like 97 yards or 104 yards or something like that. Get that accurate. Take your time with your zero distance, and getting the correct measurements for your gun to input all that into your ballistic app, and it's going to make things easier for you down the road. So I hope this was helpful. Like I said, I'll add in the post about the ballistics setup for solvers, and if you have any questions, drop them in the replies. Thanks.